numerators on top, multiply the denominators on the bottom. Everyone's good with that? Okay, so instead of doing this whole chart, I just could have multiplied 1/6 by 1/6 and gotten the answer that way. This is the multiplication rule of probability. Find the joint probability of two events occurring together. We need to multiply the probability of the first event by the probability of the second event. Multiplication rule for independent events. Independent means the second rule is not affected by the outcome of the first rule. They're completely independent. So this, you don't really need to know this symbol for this class, but this upside down U is called intersection. This means both of these events happening. This event and this event happening. Rolling a 6 the first time, rolling a 6 the second time equals the probability of the first event happening times the probability of the second event happening. You like that? Good? Okay. So let's go through some thought experiments using basic rule of probability, and then we're going to throw in the combination rule. All right, suppose you have a 6-sided die. What's the probability of rolling a 6? 1 out of 6, yeah. One single die, probability of rolling a 6, 1/6. Perfect. What is the probability of rolling a 6 twice in a row?
1 out of 36.
1 out of 36. What's the probability of rolling a 6 3 times in a row? Sounds right to me. Yeah, 1 out of 216, so that's like about 0.5%. That's right, just multiply it. I could go on, 4 times in a row, 5 times in a row. You've got it, just use the multiplication rule. What is the probability of rolling a 6 and then not rolling a 6? Oh God.
Would it be what, 1 over 6 times 5 over 6?
Yes, perfect, that is correct. 1 over 6 times 5 over 6. All right. So the probability of rolling a 6 the first time is 1 over 6, and the probability of not rolling a 6 the second time, there are 5 ways that that could happen. All right, 1, 2, 3, 4, and 5, and there are 6 possible total outcomes. The probability is going to be 5 over 36. What did we say? That was about 13.8%. All right. Is everyone good there? This is key. This point is key to our next steps. Probability of rolling a 6, probability of not rolling a 6. All right. What is the probability of rolling a 6 and then not rolling a 6 3 times in a row?
It would be 5 over 6 and 5 over 6.
Like that? Yes. All right, that is correct. So the first time, probability of rolling a 6, not rolling a 6, not rolling a 6, not rolling a 6.
125.
All right, what's it? Want to give me a decimal point for these? This is 0.138. And what's the can somebody give me the decimal point here? 0.096. All right, so about a 9% chance, 9.6% chance of this happening. You're going to roll a 6 the first time, and you're not going to roll a 6 the next 3 times. All right. Now, what is the probability of rolling a 6 exactly 1 time out of 4 rolls? how do we answer this question?
Is that not the same question?
Okay, so this, we roll a 6 the first time, and then we don't roll a 6 the second, third, and fourth time. Now my question is, well, what if we rolled a 6 here, and not here, here, and here? Alright, what if we rolled a 6 the third time? What if we rolled a 6 just the fourth time? So out of 4 times you roll the die, I want to know the chances of one of them, and only one of them, being a 6.
One out of
Is
four.
it just still the same numbers, just maybe in a different order?
Yeah, you're on the right track. Okay, so it could happen this way, and there's a 9% chance. Let's think about another way it could happen. What if it happened the second time? We could calculate that probability, right? We would say 5 over 6 times 1 over 6 times 5 over 6 times 5 over 6, and it would be the same thing, right? It would be 0.096. And we could add that. We could add this to this, and we say this is the probability of rolling a 6 this time, or rolling a 6 this time. And then there are 2 other possibilities we need to consider, right? What if we roll a 6 on the third roll, and what if we roll a 6 on the fourth roll?
So we just do 0.096 times 4?
Yeah.
Do it like that?
That's right. That's the answer. 0.096 times 4. Because there are 4 different ways that this could happen. The probability of it happening each time is 9.6%.
How'd you get that number again? You can just work that.
The 4 or
is-
the-
Is that the bottom part right there?
The 0.96?
For the
0.096?
question, the recent question, the probability of rolling is 6 exactly one time out of 4 rolls.
It's this times 4.
That times 4.
And I'm gonna continue to go over this because I'm gonna show you a different way to come up with this. So it's 0.96 times 4, which is what, 38%? Yeah, so there's a 38% chance that out of the 4 times you roll the die, one and only one of them will be a 4, or will be a 6, excuse me. Now, we were able to do that one in our head. We knew that there are 4 ways that it can happen, and we knew the probability of it happening each time. Suppose I were to ask you, is there a way we can use that combinations formula that we just learned to get to that answer faster? Yeah. How might we use that combinations formula to get to that answer faster?
4 would be N.
Yeah, something like that. So n would be 4, Yes.
X would be 6?
1.
1.
1, yeah, that's right. So, there are 4 different rolls, and we want to know how many different combinations of 1 there are. So, we want 4, combination 1. Give myself some room to work this out here. 4, 1. 4 different rolls. Question is, how many different combinations of 1 are there? So this is a little funny the way we're asking this. I don't know if you've ever heard someone say how many different combinations of 1 are there. It'll make more sense when we do combinations of 2, or it'll just sound more logical. But the math works for this as well. So, for things, take combinations of 1, 4 factorial over 4 minus 1 factorial, 1 factorial. 4 factorial is 4 times 3, which is 12 times 2 is 24 times 1, 24 on top. 4 minus 1 is 3. 3 factorial is 3 times 2, which is 6. 1 factorial is 1. So 24 over 6, 4. Okay? So we know that there are 4 combinations of 1 out of 4 different trials. So how we got to the answer is we took 4 times the probability of it happening each time. .096. And we got our answer of 0.38. All right, how are we feeling with that? Yeah?
And you got the probability with the 1 times 6 and then 5 times 6, 5 times 6, yeah.
Yes. 0.096. 4 times. All right, we're good there? All right. What is the probability of rolling a 6 twice out of 4 rolls? How are we going to calculate this problem? Twice out of 4 rolls. So I'm going to roll the die 4 times. I could get a 6 the first time, then 6 the second time, and then not a 6 the third and fourth time.
So you do the same thing, but replace 1 with 2.
We do the same thing, except we replace 1 with 2. So let's do our combination. 4, combination 2. All right, and we know from our earlier work that the answer to this is 6. How many different teams of 2 out of 4 people could we have? But let's just go ahead and crank it out anyway. 4 common factorial over 4 minus 2 factorial, 2 factorial. 4 factorial is 24. 4 minus 2 is 2. 2 factorial is 2. 2 times 2 is 4. All right, okay. And 24 divided by 4 is 6. So we know there are 6 different ways that this could happen. What's the probability of it happening each time that it does? What's the probability of rolling a 6 twice and not rolling a 6 twice? What you can do is you can pick any individual way that it might happen. So it might happen that we get a 6 the first time, probability there is 1/6. A 6 the second time, probability there is 1/6. Not a 6 the third time, and not a 6 the fourth time. That's a way it could happen, right? And there are 6 different ways that that could happen, and I would just rearrange all that. Okay, so 1/6 times 1/6 times 5/6 times 5/6. Somebody have the answer for me?
0.019.
0.019. All right. So, in order to answer this question, what is the probability of rolling a 6 twice out of 4 rolls? I'm going to take the number of combinations, ways that that could happen, times the probability of it happening each time. So I'm going to take 6 times 0.019. All right, how are we feeling with that? I see some people writing. We can take a minute.
0.077.
Oh, okay, 6 times that. Thank you.
Do you do that times 6 or times 4?
Times 6.
Oh, okay, then that's wrong.
Never mind. Okay.
0.114.
0.114. Okay, so about 11%. 0.114. 11.4%.
And that's the probability of rolling a 6 4 times?
Probability of rolling a 6
4 different rolls.
twice out of 4 rolls.
That's not the question, right? I mean,
So then for the next one,
Like,
it
what's
would be
The first part.
combination 4 and 3.
Yeah, you're on the right track, Dan. Yeah,
You would get the number of combinations, and then we would just set it up again with like,
yes,
with what we did, but just with one more.
yes.
5
with
out
the
of
nu-
6.
This would be 1/6 instead of 5/6,
Yeah.
and this
Then
would be,
multiply it again.
this would be 3 instead of 2?
Yeah.
Yes, exactly. And I think you had a question that, the question we're asking is the first one. What is the probability of rolling a 6 twice out of 4 rolls? Alright, so we need how many combinations? We could get
Like
2,
understand,
and then the probability of it happening each time comes out
right.
to.
Right, so then, what about the next question, 3 times, 4 times, what's the answer for that though?
Okay, so Danielle got us started on that. What we're gonna do is we're gonna put a 3 here instead of 2, because we're looking for it happening 3, combinations of 3. And so this is gonna be a different number.
And
And,
you just do the same for 4 for the next question.
yeah, so we'll put a 4 here instead of a 2, and then this will be 1, 6, 1, 6, 1, 6, 1, 6. Because we'll have to roll a 6 4 times out of all 4 rolls. Does that make sense? All right, any questions? All right, so that is our binomial probability function. The probability of x, which is the number of successes. In our example, it was the number of times we roll 6, equals the combination formula. N is the total number of rolls, x is the number of times we want to get a 6. So we do the combination formula. And then we do the probability of a success. In our case, it was 1/6. Times however many times we want that to happen. And we just raise that to the power of x. So, in this example, it would be 1/6 raised to the 2. 1/6 squared instead of 1/6 times 1/6. That's what this little power means. Probability of it happening 1/6 raised to however many times we want it to happen, times the probability of it not happening, which is 1 minus the probability of it happening. In our case, this was 5/6 raised to the n minus x. So this is the number of times that it doesn't happen. So for our first example, rolling a 6 once out of 4 rolls, alright, it would be 4 would be n, x would be 1. We would do the combination formula, and we would get 4, right? And then the probability of rolling a 6 is 1/6 raised to the first power, times 1 minus 1/6, which is 5/6, raised to the third power. Make sense? I'll just write it right here. Should I just do it?
Yeah.
Alright, so the probability of 1 rolling 6 once. Rolling 1/6 out of 4 rolls. Alright. Alright, so we've got 4 factorial over 4 minus 1 factorial, 1 factorial, times 1/6 raised to the 1, times 5/6 raised to the 3.
You got 3 because 4 minus 1?
Yes,
It's rolling 1/6 out of 4 rolls?
yes. Rolling 1, sorry, my writing's a little messy there. Rolling 1/6 out of 4 rolls. All right, do we like that? No? Do we understand that?
This just shortens that process, right?
Yes, yes.
So the one's like part of the formula, right?
The what?
The number one is part of the formula, right?
Yeah, 4 minus 1. So, yeah,
So that,
actually I can write it up here. So probability of 1 equals, yeah, probability of x is 1. I could put probability of this is, x is number of successes. All right, if I define success as rolling a 6,
It'd
then
be a 6.
it'd be 1, no, 1
No.
success.
One success, always one, okay.
Yeah.
Right.
And then here, this is 2 successes. I put in 2 for that. And then we could do 3 successes just like Danielle told us.
Right.
All right, everyone good here?
What was that, 5/6, the last one? 5/.
Yep, 5/6, 6. And instead of writing it out, 5/6 times 5/6 times 5/6, I'm gonna raise it to the 3rd power. Did everyone understand that? Raise it to the 3rd power? All right, great. All right, I think I have an example here. This is some fine print. The binomial, the first part is the combination that we went over. This is combination, and this is the probability of it happening each time. How many combinations, how many ways can it happen, probability each time. Like I said, some footnotes, fine print is just number of trials, what we consider a success, assuming the trials are independent, and the probability of success, and then we assume the probability remains constant in all 4 roles. Okay, let's do an example. The Wall Street Journal reports that 42% of approximately 3,500 stocks traded yesterday on the New York Stock Exchange advanced, that is increased in price. So 42% of stocks went up. If you had randomly chosen 4 stocks at the start of the day, how likely is it that all 4 stocks that you had chosen would increase in value? So, you're going to choose 4 stocks. The probability of success would be 42%. And the first question is, what is the probability of 4 successes in these 4 stocks that you chose? Kind of like rolling a 6 4 times. All right, start working on that. Let me erase some stuff and make some room. Okay, ready to do it together? So, probability of 4 successes. We need how many combinations of 4 could we have? So, oh wait a minute. 4, yeah, sorry. All right, yeah. How many combinations of 4 out of 4 things could we have? What's the answer to that, by the way? If we have 4 things, how many combinations of 4 could we have? One of those.
16.
4.
No. Suppose we have 4 people, how many teams of 4 could we have? Yeah, the answer is 1. Sounds complicated because I've taught you so much. I've taught you to question yourself at this point. So there is 1 combination of all 4. If you were to crank this out, this would be 4 factorial. 4 minus 4 would be 0 factorial, which is 1. So it would be 4 factorial over 4 factorial, which would be 1. Probability of success is 0.42. We raise that to the 4th power. Probability of failure is 0.58. We raise that to the 0 power. Anything raised to the 0 power is 1. All right, if you know the answer, just blurt it out. So this is 1, this cancels. This 0.58 to the 0 power, that's 1, that cancels. So all you need is the 0.42 raised to the 4th power, right?
0.03111.
0.0311. So about 3%. About a 3% chance of this happening?
So what did you say canceled out?
This is 1. How many combinations of 4 out of 4 stocks could you have? The answer is 1. So this whole thing is 1. And this part, the 0.58 raised to the 0 power, that's 1. So the only thing we need is to worry about is the 0.42 raised to the 4th power.
The 0.58, did you get that from the problem, or did you subtract 1 minus
Yes,
0.46?
Both. Both. It was given in the problem, but we could also confirm that by subtracting 1 minus 0.42.
Okay.
I guess yeah, I guess we wouldn't even worry about that. Good point. We wouldn't even worry about this because the formula says 1 minus this.
Yeah, I just wasn't sure if it was a coincidence or not.
Yeah. It's not a coincidence. We would follow the formula and we would subtract 1 minus this. But yeah, it would be, I guess it wouldn't make sense to the problem if it happened any other way.
Alright.
So it has to be that way. Okay, we're good there? Alright, let me see what's next. We're going to take a break momentarily, but just let me finish off this. Okay. Let's think about these next 2. Let's just intuitively think about how we would solve them without doing the calculations. So what's the probability that exactly 2 of the 4 stocks you selected increased in value? How might we set that one up?
So n would still be 4, but x would be 2. So it would be like the same equation, but with those numbers.
Exactly. So the probability is still 0.42 each one. N would still be 4, x would be 2. So we would put in 2, and we would crunch those numbers. This one's a little more complicated. No more than 1 of the 4 stocks you selected increased in value. So what does no more than 1 mean? Actually, don't even worry about that. It's a thought exercise we don't need to worry about right now. You know how to do it because you actually calculated this one out, and if you wanted to know how many probability of 2 stocks advancing, you would just put 2 in for x instead of 4. All right, so I'm gonna talk about this next slide, and then we're gonna take a break. This can be graphed in our first probability distribution. So this graph is probability, chances of stocks increasing, the chances of 0 stocks increasing, 1, 2, 3, or 4 of those stocks increasing has a certain percent likelihood. you just calculated the chances of all 4 stocks increasing. And you can see looking at the graph, it's about, here's 5%. So that looks about 3.11%. You believe me, right, that this is 3%? The chances, this one, this here, the chances of all 4 stocks increasing is about 3%. How about the chances of 2 stocks increasing? What's the probability of that happening? Yeah, about 36. All right, what are the chances of 0 stocks? So you pick 4 random stocks at the beginning of the day. What are the chances that all 4 of them decrease? 0 stocks increase. What's the probability of that happening? How much? Yeah, about 11%. All right, and how about 1%? What's the probability, 1 stock advancing?
32.
Yeah, 32. So we've got 11, 32, 36. The probability of getting 3 winners is about 17%, and we calculated the probability of 4 at 3% exactly. Or we calculated 3.11%. So I just want you to be comfortable with this. This is a probability distribution. We're going to change courses. Not really change courses. We're going to build on this. Just make sure you understand that we can graph this probability of a certain outcome on the actual outcome on the horizontal axis. It could be 0, 1, 2, 3, or 4. And the probability of that happening on the vertical axis. Probability distribution. Make sense? Okay, great. 10 minutes a good break time. I find that's enough to take a little break, but the sooner we get through it, the sooner we can go home. Does that work well for you? All right, so let's come back at 8:18.
No, you can sit there. Better.
So he records his lectures, we can just go on there. They made you work on
Yeah, today, another.
I don't know where
I don't even know where the gym was for the class did. I was like, you know what, I'm just staying right here. And I went to the main campus, the girl had to leave because I was like, I'm already going. So now that I know, I know. I was like, my first day of this, I'm like, oh yeah, I want to do that.
You know what, he records everything. So we can go on there and we can play
Yeah, when I came in, you
everything.
were showing me how to print out, just go on, the
You go on
course
the
plan.
Blackboard,
Oh, the Blackboard.
Yeah.
And you go to his
there's a
specific
link for it. You
class.
sign up, and before you sign, you go to Blackboard,
Uh-huh.
put your credentials, like, and then you go to the university today.
Yeah, the
Then you
username and all
just,
that stuff.
course, make sure you click on the right course, and then the course you're taking.
True,
Then
true.
you go to the assignments, and you just click on things, and it'll show everything in there.
Okay, good.
Yeah.
So, yeah, that's good. So you guys go here? You guys go here? Because when was your first time?
I was struggling to get 60% on that con, so, and it was good.
I know, right? Everything else, was like, all right.
And like, if I want to see another guy.
I know,
I want to see guys, I don't want to see his better cards. No. I don't want to see that.
No.
Actually, I find it easier, like with his Wall Street thing, like this looks, like this.
You can read through it and then just
But
kind
the
of
other one,
like.
you gotta really think, okay, how many times
It's
can
not-
you throw that?
Yeah.
4 minus
You
4,
gotta
which
like
is
think
0.
about it.
I'm like, oh my gosh. Yeah, I need to.
This is like the second edition, it's supposed to be the same thing. Which one? Who has the book? Anyone have the book?
Yeah.
Yeah. Just wanted to compare, I got an older version.
Oh, okay. Yeah, I just got this today, so. Look, what's this? This is-
I just take a quick peek if you don't mind.
Yeah. It's all loose stick.
Oh, okay, I'll be careful.
Yeah. That way I'll just put it. Yeah, there's gonna be a little bit easier, like I don't have to like worry.
I got an older version.
So where'd you get yours? You got it from the store?
No, I got it from Amazon.
Amazon?
I got, well, this is someone else, but I got an older.
But it's pretty much the same.
It is, yeah, I'm actually comparing it now, it looks like to be the same. I paid $40.
How much is it going? 140? Yeah, so I would be,
I paid
I know.
I paid 45. It seems like the same thing though. It's the second
I'm
edition.
pretty sure, like,
I get the book in the back, I just think it's $3.99. Yeah, they got it for $3.99 and sold it to me for 45.
That's really, that really,
no,
that much of
it
a
isn't.
difference, it's just how you rearrange.
I mean, what they changed, just one word? I mean, geez. That's crazy, that's a lot of money.
Yeah, that's the.
You get a digital.
It is, that's just the instructor's book.
Same thing. I Googled to see if it was the same thing. They said it was the same thing. That's why I got it. I wasn't sure.
Yeah, but that one says that they will get it between December to 2020.
Right, because now it's like the holiday season.
Yeah, it's the same thing.
What is Barnes and Noble?
You only use like 10 weeks?
That's a lot of money. Exactly.
Lot of money.
Rent it though.
Yeah, I'm definitely going to do that.
That's what I think I'm gonna do.
Yeah.
Because I know once you make it to certain classes, I'll be scared to look at the book again. This right here. Just get a good grade, and then I'm gonna do foreign background.
There's a bookstore here. I think most people rent it from Check. I think you can rent it here.
That's where I was then. Leah.
What's the
.com.
Shane?
Shang. CHEGG. Because I remember the kids in college that did that. That's what I'm gonna do.
Someone left their USB in this computer.
Ricardo, is there Ricardo show up? Jasmine?
I have to just review it
Precious?
one more time.
Right here.
It's pretty, it's easy, it just, it's, brain cells are still. Cause all this was under car.
Kyle? Yes.
That's true,
They
well, that,
had those scenarios where, they even had the Wall Street one there too.
yeah.
And they have one where voting like if you keep your friends, how many do you get to?
Right.
That was the combination.
Morinette. Am I saying that right?
Yes, but you can, it's Maury, I thought they had shortened it, it's Maury, and it's easier.
Maury?
Maury, yeah.
Maury, okay. Maury. Alright. So just no Ricardo and no.
Oh, right here.
Oh, Ricardo.
Hey, you want to take a picture of it?
Alright, just no Jasmine.
That guy, that's one.
He said he was from Brightwood, and he told us there's not much difference.
Oh, really? I guess, you know, all of this stuff is being created. It's not in the book, it's just
Right,
the quizzes are on the computer. That's what it is.
right.
So you know the concept, you know. And you know the concept. I mean, I need to make sure I have my.
Excuse me, I'm gonna check this camera. Worried about whether or not it's at the right angle.
Professor, you record all your lectures then, right? And it's
Yes.
on our blackboard and we can go.
Yes, yes.
Okay.
Alright, looks like we're good. Just can't stand too far that way. Yeah, they're all under class video recording, under my or,
The black, the course, yeah.
yeah, my course or whatever,
Right.
course materials,
Right.
that's it. Alright, so let's get started. So tonight, it looks like we're gonna go pretty close to 9:30. I will definitely make an effort to do one of two things, either get you out a little bit before 9:30, or if we go all the way up to 9:30, at least make sure you're learning something important. Tonight's one of those nights, we'll probably go right up till 9:30, yes?
So the stuff we're doing now is for the test, that's the next week?
Yes, yes, yeah, so they'll, on the syllabus on page 3 and 4, there's homework problems associated with this, and with other things I'm gonna teach you in the next hour. Do those homework problems, you should be all set for the test. If you have any other questions, you can ask me. I don't know if you saw me go over the Excel worksheets and all that, I can show you that after class. Alright, so before the break, we learned the binomial probability distribution or binomial probability function. We use that to calculate number of successes, and we came up with our first probability distribution. Probability distribution has a couple of important features. On the horizontal axis, it has the outcomes. On the vertical axis, it has the probability of that outcome happening. All right, so what I'd like to do now is use the binomial distribution to create another probability distribution. I would like to use an example where we are flipping a coin, a fair coin. Suppose we flip it 20 times. The probability of it coming up heads each time is 50%. And what I'd like us to calculate, we won't do them all, we'll do a couple. I would like to calculate the probability of 0 through 20 successes. So let's do one together. Suppose we want to calculate the probability of 11 successes in this 20 coin flip experiment. So we're going to flip a coin 20 times. I want to know how likely is it that 11 of those coin flips will come up heads. Does everyone understand the question? All right. So what is our n in this scenario?
11. 20.
20, yes. What is our x in this scenario?
11.
Number of successes, exactly. What's the probability of success each time? 0.50, outstanding. So, all right, the probability of 11 successes equals 20 factorial divided by 20 minus 11 factorial times 11 factorial times 0.50 raised to the what?
11.
Outstanding. Times 1 minus 0.50, which also happens to be 0.50 raised to the what? 9. Outstanding. Perfect. All right. So, does anyone have the answer? If not, I don't want to wait for it if it's going to take a while. Just move on. I'm impatient like that. All right, so that's how you would.
0.002.
0.002. So about 0.2 of 1%. No, that's not right. I don't think. All right. So actually, maybe I'll assign someone to do this one and actually get an answer. Maybe could you 4 in the front row? Could you do this one? Probability of 11. Maybe could you 3 in the back? Could you do 12? The probability of 12 coin flips coming up heads. Probability of 12 equals. And maybe could you 3? Could you do 9? Probability of 9. And then maybe you 4 in the back row. Could you do, let's say, what have we got? We've got 11.
12, 9.
Let's do 10. All right, you in the back row, do 10. All right, so you all in the back row are doing 10. You 3 are doing 9. You 4 are doing 11. You are doing 12. All right.
Oh, yeah, it would be, put the X would be 10 instead of 11.
Oh.
Yeah.
No, we just times it.
Feel free to confer with each other. As long as you're on the same team.
I missed the factorial on the other one.
Okay, so that's 2.5 times 14, which is 11.
I don't know, like, that's why I'm like.
It's a percentage between 0.
So this is going
Say,
Alright,
did I fit on my phone?
I got it.
What'd you get?
It's not.
12. 12.6?
0.1.
This one.
17.6. That looks right.
0.17.
Yeah, 17%.
Yes.
Yeah, yeah.
With this one, is this,
Because there's 20.
the 25 like a crazy.
Yeah, that's like 2.4 trillion times
But
10
it's
to
like
the
2.5.
So what I did was I figured out,
And the other one was
So
not.
we try to try to
Right.
factorial.
Right.
So 20 minus 11 factorial is 262.
That's right, so 5 factorial is 120. So,
Wait, so, yeah, that's where I get
I might be doing this
2.4
wrong,
trillion.
because I have 4.
okay, alright, so it's not 2.4 trillion. Billion trillion, actually. It's like billion zillion
Yeah.
trillion.
Yeah, it's a long number.
Alright, who's got a reasonable answer for 11? Reasonable answer should be between 0 and 1.
Yeah.
And then you divide that number.
Alright, that one? Reasonable answer for 12?
You should like 180.
Come on, for 11 I even wrote it all out for you. Still didn't get it? It's fine. It takes a minute to get used to the calculator. Like I said, I can help you a little bit after with your calculator if you like, or you can just kind of get used to it between now and next week. Maybe you'll probably want to do it on Excel. That might even be an easier way to do it. All right, anyone have a reasonable answer for 12?
12%.
0.126? Is that, it's just 12%?
I didn't go that far.
I-
Oh, that's all right, that's fine. Okay, I like 12%. How about 9?
I set it up beautifully, but I don't know what I'm doing wrong on my calculator.
Okay, anyone got 10? Oh, yeah,
17.6%.
17.6%. All right, excellent. So I've got all these calculated out. So for 12, the answer is I get about 12%, which is right. Yes. For 10, I get about 17.6%. Yes. For 11, if we'd gotten that far, I'd get about 16, just a little under 16%. And what else are we missing? For 9, the answer should have come out to just a little under 16%. So we may not have gotten all these answers, but we got a few of them, and you knew how to set these up. So if you had some more time, you could crank out each of these. The probability of 0 successes, flipping the coin 20 times and getting 0 heads, would be this tiny, tiny percent. Can't even see it, it's so small. And all the way up through 20. Let me give you a minute to absorb that. We'll talk about what that means. Does everyone understand at least how we would have constructed a probability distribution like this? So,
Can you just do the first part of, the probability of 12?
yeah, sure.
Can you write out the whole formula for 12?
Just the first part, because these numbers are so,
All right, so the probability of 12 successes. First, we need how many combinations of 12 out of 20 coin flips could there be? So when we're flipping this coin, we could flip all 12 first ones, be heads, and then 8 tails, or any other sort of combination of that. So that'd be 20 factorial, 20 minus 12 factorial, 12 factorial, times 0.5.
I just want you to do that part right there, the first part, before you go.
Oh, you want me to do
Yeah,
this?
because I got the rest of it.
Okay, fine. All right, so 20 factorial over 12 minus 20 minus 12 is 8 factorial, 12 factorial. All right.
My numbers are so large, that's.
Yeah, this is like 20, that's like 7 zillion.
Okay, so it's not just.
So you need to keep it in your calculator,
Uh-huh,
or you need to do like parentheses or something like that.
uh-huh.
Yeah. We're doing it in Excel.
Yeah, see, I'm doing it too, and I still keep getting huge numbers. I'm
Me
getting
too.
exponential numbers.
Yeah, but on that TI thing here, you can do parentheses is probably the way to do it. I can't do it. I'm gonna get dizzy and confused.
Oh, no, I can, maybe I should try parentheses then.
Yeah, parentheses is a good way to do
So
it
do they
there.
all go in the parentheses, the X?
These, well, so what you'll do on your calculator, you'll do 20 factorial divided by parentheses, 8 factorial times 12 factorial parentheses. Okay, so it may take a minute to play around with that calculator, but you should definitely invest that time doing that. It's just something a MBA student needs to be fluent with.
Is it
Right, Jenna?
125,970?
The answer? No, it's a number between 0 and 1, and for 12 it is 12%.
It's 12% for as well.
Yes, eerie coincidence, isn't it?
Oh, okay.
So we'll call it 11.99%.
Got it.
Okay, all right, so let's take our focus off the calculators for a minute. Definitely something you need to invest some time into to get fluent with, but let's try not to do that right now. Let's just first pose the question, are you comfortable with how we would have gotten all of these numbers? No, who can blink first? All right, you are, right? We just put them in the binomial function that we all know and love now. For 11, we'd set it up just like this. And imagine you put the parentheses in your calculator the right way, you would have gotten the right answer.
Is there a quicker way to do that than do it 20 times?
Do what, 20? Oh, yeah. I don't know, you could do it in Excel, you could do some sort of pivot table. Yeah. I think that's what, I did the to build this graph, I did the formulas, and then I don't know what I did. I didn't do it 20 times, I like, you know, I wrote out 1 plus what I don't know what I did. That make sense?
Sort of.
So I wrote out 1 through 20, and then I did some sort of combination formula, and then I set up some formula. In fact, I think you may even get to do it for your homework for Excel. All right, so again, are we comfortable with the way you would have gotten these numbers? So if I ask you, what's the probability of 5 successes flipping a heads 5 times out of 20 flips? Are you comfortable with how you could have told me the answer is 3%, or on your calculator it would have read 0.03 something? All right, no one's going to say yes. Maybe I could ask the question a different way. So silence means yes. Yes? Yes? You can lie to me. It's all right. Just say yeah.
Yes, yes.
Yeah.
I think we get how to set it up, we just don't get how to solve it, because
Yeah,
like,
those
the calculators are
numbers
not
These
helping.
numbers are huge.
Yeah.
All right, so
But I
then,
think we could all set it up.
How do you set
We
it
can
up?
write that formula out.
Yeah.
Yeah.
The formula we understand.
Yeah.
all right,
It's
you
just solving it.
understand the formula. Your challenge between now and when you take the quiz for this class is to make sure you can do that on your calculator, or you can do that on Excel. Because you'll have a problem exactly like this. It'll be like, what's the probability of so many successes out of so many trials, if the probability of success each time is whatever percent. It'll be just like that, and you'll need to give a percentage. Okay, so we know how to set it up where each of these